All right, my friends, let's go ahead and make a review up in here. Mrs. G. That's a subtraction. So -4 minus -8 is 4. 5i minus -7i is 12i. Just combining your like terms. Can combine the -7 and the -3, so that's a -10, and the -4i and the -8, so that's -12i. This next one, I gotta distribute. Pew! -18. Pew! -6i. Pew! -3i. Pew! -i squared. -6i and -3i makes -9i. -i squared is the same thing as +1, so -18 plus 1 is -17. For this next one, theoretically I need to multiply the top and bottom by the complex conjugate. So we do that, and we do that, and we distribute the top, so that's 16 minus 24i, sorry, I forgot to view, minus 8i, pew, and plus 12i squared, pew, and then, pew, 16, minus 24i plus 24i, so those will go away, minus 36i squared. Now let's simplify. -24i and 8i is -32i. That's actually a minus 12, because I squared is -1. 16 minus 12 is 4. That's a plus 36. 16 plus 36 is 46, 52. If you wanted to, you could reduce everything by a factor of 4. So 1 minus 8i over 13, that would be I. What do we got next? Given the graph, write an equation. You may leave your answer in factored form. All right, so I really only need that part. I see a -1 as a 0, so I'm going to write that as x plus 1. And it looks kind of cubic-like, so I'm going to put a 3 on it. And I see a 2 as a 0, so I'm going to write x minus 2. And that looks kind of quadratic if I were to zoom in. See, I'll show you. Whee! So I would write that as x minus 2 squared. There may be an a value in front. Let's go ahead and plug in that point, 0, 4. So 4 equals a times 1 cubed times -2 squared. 1 cubed is 1. -2 squared is 4. So that means 4a is 4, so a is 1. So I'm just going to go ahead and erase the a there. And I did it. So good, right? Given the function, state the zeros. That looks like I might be able to factor it, so let's go ahead and try. 4 times 9 is 36x to the 4th. Middle term is -12x squared. Come up with things that multiply to 36 and add to -12. That feels like 6 and 6, right? So we're going to split that middle term. 4x to the 4th minus 6x squared minus 6x squared adds to -12, multiplies to positive 36. This is technically equal to 0. Factor out a 2x squared. I'm left with 2x squared minus 3. I'm hoping for a 2x squared minus 3. Let's see if I can make that happen. If I put a 3 there, that is negative. When I distribute that back in, that would make -6x squared plus 9, so that works. So I got 2x minus 3, 2x squared minus 3, and I'll also have 2x squared minus 3, so I have them twice. That equals 0. So I can take the square root of that, so I'll have 2x squared minus 3 equals 0. I'm going to add 3, divide by 2, take the square root, and put a plus or minus. So those are the zeros. Plus or minus root 3/2. They both show up twice. State the y-intercept. When I plug in 0 for x, I get 9. So 0, 9. And state the end behavior. It was a positive quartic. So the end behavior is going to look like that. I know I'm going to have a 0 at root 3/2 and a 0 at negative root 3/2. I know I'm going to go this way, and I know that the y-intercept is 9. So I would just draw the curve something like this. Boop, 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 boop. I did it. That's it. Divide the polynomials. Okie dokie. X cubed plus 2x squared minus 87x, 87, plus 56, divided by x minus 8. How many times does x go into x cubed? Or what times x is x cubed? That's going to be x squared. Distribute that. Pew, pew. So distribute that to both the x and the 8. Subtract down. You get 10x squared minus 87x. How many times? What times x is 10x squared? That's 10x. So, pew, 10x squared, pew, minus 80x. Subtract down. That's going to be negative 7x plus 56. So let's put a minus 7 up here, because negative 7 times x is negative 7x plus 56. Subtract down. Oh, look, I get 0. It says state what that means. Well, I got a remainder of 0. That means x minus 8 is a factor. Given 4 and negative 4 and 1 are zeros, find the other zeros. Okay, I have some choices here. I think what most of us are going to do, I'm going to do what most of us are going to do. 6x to the 4th plus 7x cubed, or at least my guess on what you're going to do, plus 56x minus 16. Divide that by the first one, x plus 4. So I'm going to put a 6x cubed plus 24x, 6x to the 4th, 24x cubed. Subtract down. 7 minus 24 is 17. Now I'm going to have a negative 17x squared. So negative 17x cubed. 40 and 28 is 68x squared. And I get 15x squared. Bring down my 56x. And that's going to be a 15x. So that's 15x squared plus 60x. There's an x there, I forgot to write. Subtract down. And I'm going to get negative 4x minus 16. Minus 4 gets me negative 4x minus 16. 0. So I got a 0. Cool. I should have. So 6x cubed minus 17x squared plus 15x minus 4. Divide that by, was it 1? Yeah. X minus 1. So 6x squared. 6x cubed, 6x squared, subtract down, negative 11x squared plus 15x, negative 11x, negative 11x squared plus 11x, subtract down, 4x minus 4 plus 4, 4x minus 4, subtract down, and I get 0, which I should. Now I have a quadratic. 6x squared minus 11x plus 4. Oops. 6x squared minus 11x plus 4 equals 0. I need things that multiply to 24x squared. I'm hoping I can factor this and add to negative 11. Feels like 8 and 3. So 6x squared minus 8x minus 3x plus 4 equals 0. I can take a 2x out of 6x squared and 8x, so I'm left with 3x minus 4. I would like a 3x minus 4. If I plop a negative 1 there, I can make that happen. So I wind up with 2x minus 1 and 3x minus 4. That means x is going to be 1/2 from the first ones and 4/3 from the second. And that answers the question. Now I said there was a different way to do it. There is. I could have taken the x plus 4 and the x minus 1 and distributed that out, and you'll wind up with this. And I could have divided the original thing by this quadratic, would have been much faster, and gotten to the same 6x squared minus 11x plus 4. That would be what I would do because it would be more efficient, but I don't think it's as intuitive for you, and therefore I don't know that you would do it. If you use synthetic division, that's fine also. Whatever makes you happy.